In this video, we're going to talk about random variables. And in our case, we're going to stick with what are called discrete random variables, things that can only take very specific values. And the random comes from the fact that these values can't be predicted except in a statistical sense ahead of time. Now, Chifaru loves playing D&D with her friends. This is a game where most of your statistics and most of the events that happen are determined by rolling a very specific dice. And then the last time they got together, she noticed that one of the four-sided dice, with numbers 1 through 4 on it, was acting pretty strange. So she's a big nerd, and she loves to understand what's going on, so she spent the entire weekend rolling this die over and over again to estimate the probability distribution of the rolls of that dice. She knows that if this four-sided die is fair, then each of the four sides have the same probability of coming up, right? So they'll each show up about 25% of the time, so a probability of 0.25. The test that she did over the weekend showed that the probabilities that she noticed were as follows, right? She rolled a 1 with a probability of 0.14, or 14% of the time, rolled a 2, 22% of the time, rolled a 3 with a probability of 0.27, and a 4 with a probability of 0.37, right? So it sure looks like the higher numbers are much more likely than the lower numbers, right? Much more likely to roll a 4 than a 1, more than twice as likely, almost 3 times. So this indicates that the die may not be fair. We'll talk a little later in this semester about exactly how to calculate the likelihood that this is still a fair die, just she got some quirky rolls. But for the moment, let's just take these probabilities as they are. All right, first some language. We call this kind of distribution a discrete probability distribution. It's discrete because our variable can only have very specific values. The die can only land as a 1, a 2, a 3, or a 4. It's a probability distribution because each of the probabilities are between 0 and 1, and they all add up to 1. Sum p of x is going to be equal to 1. Right. I double-checked. It actually works this time. One of the things that we like to know about the things that we measure is the mean of distributions, right? For a discrete probability distribution, we call the mean the expected value, okay? Basically, if we roll this die over and over again, the mean of those rolls will be the expected value. We'll show how to calculate that in a next group of slides. All right, so how do we calculate the expected value? Well, we take our value x, multiply it by its probability, and then we add all of these up, right? So we take 1 times 0.14 plus 2 times 0.22 plus 3 times 0.27 plus 4 times 0.37. It's going to look like this. All right, so here's a calculation of the expected value of this discrete probability distribution. All right, now we grab a calculator and we pop it out, and what do we get? We get that our expected value is 2.87. If you want to go back and calculate the fair die, the average would be about 2.5. So this is a little on the high side. And exactly what does this number tell us? Well, it tells us that over the long run, the average value of the rolls will be 2.87, right? They're going to be a little higher than the 2.5 that the fair dice would be. So this die is not giving good fair rolls for our Dungeons and Dragons players. Well, what else do we usually like to calculate with these statistics? We like to calculate the standard deviation. So how do we do that with a discrete probability distribution? All right, so Our mean is our expected value, in which this case is 2.87. And remember that the standard deviation is the square root of the variance. And previously, variances have been a little easier for us to calculate. So, how do we calculate a variance if we are forced to do it by hand? Well, in this case, what we do is we take the square of our x values, right? We square these guys. We take each one of them, multiply them by our probability, right? Then we add those things up. And then we subtract off the square of our expected value, of our mean. So for this example, it's going to look like, so it's the squares of our data values. It's a four-sided die, so we have a 1, 2, a 3, and a 4. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Square those, multiply them by their probabilities, add them up, and then subtract off the square of the mean. This makes the variance for our discrete probability distribution 1.331. Okay? So the standard deviation is the square root of the variance, and that makes it square root of 1.1331, which is 1.06. All right? So, give these a look over, give this section a look in your book, and we'll talk about it next class.